Good morning, everyone. Today, I, Jyotika Duteja of Pandit Jawaharlal Nehru College, will teach you something about groups and subgroups. First of all, we'll start with binary operation. What is binary operation? In this, we take a non-empty set A and we define a mapping star from A cross A to A such that x comma y goes to x star y. And if x star y belongs to the codomain A, then we say that my star is a binary operation. And we also say that the set A is closed under my binary operation star. So in other words, an operation which combine two elements of a set to give another element of the same set is called a binary operation. Binary operation is also known as binary composition. Example of a binary operation. Ordinary addition on the set of integers is a binary operation, since we know addition of two integers is again an integer. Next example is ordinary multiplication on the set of integers. We all know that if we multiply two integers, then we get another integer. Therefore, multiplication is a binary operation on the set of integers. Next example is addition on the set of irrational numbers. It is not a binary operation because if we add root 2 with minus root 2, then we get 0, but 0 is not an irrational number. Therefore, addition is not a binary operation on the set of irrational numbers. Multiplication is a binary operation on the set of natural numbers, integers, rational numbers, real numbers, complex numbers. As we know, combination of these numbers will give the resultant in the same set. Next, multiplication of the set of irrational number is not a binary operation, because if we take an example, as if we multiply root 2 with root 2, then the resultant is 2, but 2 is not an irrational number. Therefore, multiplication is not a binary operation on the set of irrational numbers. Subtraction is a binary operation on set of integers, rational numbers, real numbers, complex numbers, but it is not a binary operation on the set of natural numbers. For example, if we subtract 2 with 2, then we get 0, which is not a natural number. Next is a division is not a binary operation on the set of natural numbers, integer, rational numbers, real numbers, complex numbers. Next, very good example of binary operation is exponential operation, which goes as x comma y goes to x to the power y. It is a binary operation on the set of natural numbers, but it is not a binary operation on the set of integers. Next is some fundamental properties of binary operations. First property is associativity. In associativity, we see whether the combination of three elements in different order gives the same result or not. For the binary operation, if we combine first two elements and the result of these two elements combined with third element gives the same result as if we combine the last two elements and the result of the last two elements combined with the first element. That is, A star B combined with star C is equals to A star B star C. So the order of the combination matters here. But for the binary operation, it is equal, so binary operation satisfies my associativity. For example, if we take A as 4, B as 5 and C as 6 and our set is natural numbers, so the multiplication of these three numbers, whether done in any order, they give the result 120. So the order doesn't matter in the set of natural numbers for the binary operation multiplication. Next property is distributivity. Distributive property is a similar form of associativity. In this also we take three elements, but in this property we have two different binary operations combining three elements, such as A star BOC is equals to A star B O A star C, or we can say it in another form as BOC star A is equals to B star A O C star A. So for example, if we take A as 2, B as 5 and C as 4, Then we are combining A star BOC as A cross B minus C, which is 2 cross 5 minus 4, and it gives 2. And another, on the right hand side, we have A star B O A star C as A cross B minus A cross C. So it gives the same result as 2. So distributive property is satisfied on the two binary operation multiplication and subtraction on the set of natural numbers. Next property of binary operation is identity element. What is identity element? Identity element is an element which combined with another element gives the another element. So basically, such as if we take 1 in the binary operation multiplication, then any number multiplied by 1 will always give that number. So 1 is my identity element for the binary operation multiplication. And if we take binary operation addition, then 0 is my identity element for the binary operation addition. Next property of binary operation is inverse element. What is inverse element? Basically inverse element is an element such that if we combine it with the another element, then it gives the identity element, which is A star B is equals to B star A is equals to identity. So A inverse is invertible if A star B is equals to B star A is equals to identity, and we also say that A inverse is equals to B. So 1 is invertible when star is multiplication. Next property of binary operation is commutativity. It is similar to my associativity, but in this property we take only two elements, and the property says that combination of two elements done in any order gives the same result. That is, A star B is equals to B star A. For example, addition on the set of natural numbers, that is, if we add 8 and 9 in the order 8 plus 9, and if we add it as 9 plus 8, so it always gives the result 17 whether done in any order. So commutativity has two elements and associativity has three elements. The main thing is the order in which we are combining the elements. Next is composition table. What is composition table? In this, we take a finite set, and the representation of the binary operation in the form of table is basically my composition table. For example, if we take the set of cube roots of unity, then it has three elements. So it is a finite set, therefore we can make our composition table for this set. It has three elements, 1 omega omega square. Let us draw its composition table. First of all, we have to know that what is the binary operation on this set. For this set, we are taking the binary operation multiplication. Then first of all, we'll write the elements in the horizontal form and then in the vertical form. And then we'll start combining the elements with the help of binary operation multiplication. First, we'll combine 1 with this 1, and resultant is here 1. Then we'll combine 1 with omega, and the resultant is omega. Then we'll combine 1 with omega square, and the resultant is omega square. Next, on the next element, we'll combine omega with 1, we'll get omega. Next, we'll combine omega with omega, we'll get omega square. Then we'll combine omega with omega square, then we get omega cube. And we know the property of cube roots of unity. We have omega cube is equals to 1. Then omega square into 1 will be omega square. Omega square into omega will be omega cube. And then omega square into omega square is omega 4, which is omega. So our composition table is complete. Here we have combined the elements with the binary operation star of the set G, which is cube roots of unity, and it has three elements, 1 omega omega square. And we have seen that all the elements in this composition table belong to my set G. Next, some questions on the topic that we have done today. The first question whether division is a binary operation on natural numbers, or whether subtraction is a binary operation on natural numbers. So if we take division in the set of natural numbers, then we obviously know that if we divide two natural numbers, then the resultant will always not be a natural number. For example, if we take 5 and 3 and we divide 5 by 3, then 5 by 3 is not a natural number. Therefore, division is not a binary operation on natural numbers. Next is subtraction. Subtraction is not a binary operation on natural numbers. We have already done this. For example, if we minus 2 and 3, if we subtract 3 from 2, then we get minus 1, which is not a natural number. Therefore, both division and subtraction are not binary operation on the set of natural numbers. Next question: are all binary operations closed? Then it is not true. When we say all binary operations are closed, when we say whether a binary operation is closed or not, binary operation is closed when if we combine any two elements of that set and the resultant is again in the set, then we say the binary operation is closed. But all binary operations are not closed. For example, if we take a set of odd integers and we take binary operations as addition, so we know if we add two odd integers, then the resultant is not odd, it is never odd. So it is never odd, so the resultant will never belong to that set of odd integers. Therefore, all binary operations are not closed. Next question: is square root a binary operation? So what exactly is a binary operation? We have already done it. So examples: so it is not basically a binary operation. You cannot take a square root of each number and think that it will belong to our set. Some non-binary operations, such operations are called non-binary operations, like square root, factorials, absolute values. Such things are called non-binary operations. Non-binary operations are which are not a binary operation. Or we can say a non-binary operation refers to the mathematical process which only requires one number to achieve something. And in this binary operation we need two elements. So basically combination of two elements gives me a binary operation. And in a non-binary operation we just need one number. Like we can calculate a square root of just one number, we don't need another number for it. But addition, subtraction, multiplication and division, for such operations we need two elements. So these are binary operations. Next question: what is identity element? Identity element in a binary operation, we have already discussed this, is the element which when operated with any element of the set gives the set as unaffected. Basically, it doesn't affect my element when operated with any element of my set. Or we can say, if we combine an element with the identity element, then it will always gives me the first element of the set. So this is the last question. I hope you have enjoyed my class. Thank you so much.